Hello. In this video, I will do example 3 of trigonometric substitution. So on this substitution problem, I gotta evaluate, and it's the evaluate at the integral of dx over parentheses 4x squared minus 9, all raised to the 3 halves. So the first step is figure out which is the appropriate trig substitution. So if you look at the bottom, we have 4x squared minus 9 all raised to the 3 halves. So it's most likely to use this rule. So what that means is our b is going to be, I believe our b is going to be 2, and our a is going to be 3. So we're going to use the equation x equals a over b times secant theta. Okay. So our a value is 3 and our b value is 2. Because if you compare it with this, the b is the number in front of the x squared, and then the a is the number related to the constant. So if our a is 3 and our b is 2, we're going to use the substitution x equals 3 over 2 times by secant theta. Okay. Because we have an x squared, let's just find x squared. So what is x squared going to be? It is going to be, so you square this whole thing. So 3 over 2 square is, when you square that, that's 9 over 4. And then secant square is secant square theta. Okay, so now what we're going to do is substitute it back into our problem. So it's going to be the integral of 4 times x squared, which is 9/4, secant square theta. And then it's still inside the parentheses is that minus 9. And then we're all going to raise it to the 3 over 2. Okay. So if I clean this up a bit, what can we do? So on the parentheses, if I file out this 4, what cancels the 4's cancels. So you're just left with 9 secant square theta minus 9, all raised to 3 over 2. Okay. Okay, so on the bottom, what can you do? You can factor out 9. Right, on the bottom you can factor out a 9, so this would be 9 parentheses secant square theta minus 1 raised to the 3 over 2. Okay, now what can we do? So did you know that this is all raised to the 3 halves? So really this is not really a 9, it's actually, so if you simplify this, on the bottom, it's not really 9, it's actually 9 raised to the 3 halves. So what's 9 raised to the 3 halves? It's wait, actually, well, before we do that, secant square minus 1. That's a trig identity, and the trig identity would be tan square theta equals to secant square theta minus 1. So this is one of your trig identities. So what you can do is replace secant square theta minus 1 with tan square theta. Oh, and then this is all, remember, this is still all raised to the 3/2. Okay, so let's clean that up. So on the bottom, what's 9 raised to the 3/2? That would be 27. Now, what about the tan square raised to the 3/2? So remember the rule when you raise, you multiply the power. So you're just multiplying 2 times 3/2, which the 2's cancel. So you're just left with tan cube. So what can you do next is you can factor out this constant. Remember, this is a fraction, so it's 1 over 20, 1 over 27. So you could factor out 1 over 27. And then on the bottom, you're just left with dx tan cube theta. Okay, so what do we do next? Well, the thing is, we have a dx and a theta, so we have to put it in terms of theta, right? So what we know is that x equals 3/2 secant theta. And then let's take the derivative of this. So this is dx over d theta. And the derivative of 3/2 secant theta is, what is the derivative of 3/2? So you could take out the factor out the constant, right? And then you just take the derivative of secant theta. So the derivative of secant theta is secant theta tan theta, right? So the derivative of this whole thing is 3/2 secant theta times it by tan theta. Okay. Then what you want to do is get rid, because we want to just get rid of, we want to get dx by itself, so I have to get rid of this d theta. So to do so, I'm going to multiply both sides by d theta. Okay, so this cancels, so you're just left with dx equals to 3/2 secant theta times tan theta times d theta. Okay. So now what we could do is replace this dx with 3/2 secant theta tan theta d theta, right? So that is what I'm going to do. So I'm going to replace dx with that whole thing, this whole thing. So what you could do is simplify this. What can you do? You can factor out this constant 3/2. So you have a, keep in mind you have 1 over 27 for still. And then if you took out this 3/2, just take it out. We'll clean that up a bit. And then you're left with secant theta tan theta. Okay. So what you'll do next is simplify. What can we do? What can we cancel? Well, I think you could cancel this tan theta, right? You have a tan theta 1 over tan cube theta. So that cancels. And then this just becomes a 2. So you're left with So on 1 over 27 times 3 halves, that's just 1 over 18. And then you're left with secant theta over tan square theta d theta. And then simplify this. So let's put it in terms of cosine and sine. So we know that secant theta is the same thing as 1 over cosine theta. And then we also know that tan square theta is sine square theta. Over cosine square theta. Okay, we have a complex fraction, so we can simplify this. So it looks like our LCD is cosine square theta, so you're going to multiply the numerator and denominator by cosine square theta. Okay, so cosine square theta times 1 over cosine theta is just cosine theta. And then on the bottom, cosine square theta times sine square theta over cosine square theta. So you're left with sin square theta. Okay, so this whole thing simplifies as cosine theta over sin square theta. And then you have a d theta. Okay, so how do we integrate cosine theta over sin square theta d theta? Well, what do we know? We can do u substitution, right? So what should I use my u? Maybe I can use u as sin theta. So du would be positive cosine theta d theta, right? So that works out just nicely. Okay, so this would be u squared, and then you replace cosine theta d theta with du. So what is the integral of 1 over u squared? It is not ln, right? It would work if it was 1 over u, that would be ln, but what we can do is just take the integration rule. I can rewrite 1 over u squared as u to the negative 2 du, and then this is 1 over 18, right? So what is the integral of u to the negative 2? So you just remember the integration rule, you just add 1 from the power. So what's negative 2 plus 1 is negative 1, and then divided by negative 1. So it would be negative 1 u to the negative 1, and then you still got to times it by 1 over 18, and then the plus c. So this simplifies as negative 1 over 18 u plus c. So this is going to be negative 1 over 18. And then our u we said was sine theta. Plus c. Okay, so is this our final answer? Unfortunately, no. We have to go further because our final answer has to be in terms of x. So this is where you have to draw the right triangle. So let's draw our triangle, our right triangle. And let's put theta here. So what do we know? Remember we said that our x value was 3/2 secant theta, correct? So if you forget, you might have to rewrite the SOHCAHTOA. Then what I would do is solve for just regular secant theta, so I have to get rid of this 3/2. To do so, you can multiply both sides by the reciprocal of 3/2, which is 2/3. Okay, so on the left, it's just going to be 2x over 3. And then on the right, the 2/3 cancels with the 3/2. So you're just left with secant theta. Okay, so this is what we're going to use for our right triangle. So what is secant theta? Well, I know it's related to the cosine, right? Cosine is adjacent over hypotenuse. So secant is just a reciprocal of cosine. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent. So this 2x is your hypotenuse, and then this 3 is your adjacent. Okay, so this, you can replace this hypotenuse with 2x, and then adjacent side of theta will be 3. Okay, so in order to find sine theta, we need to figure out this missing leg. So we're going to, since it's a right triangle, we could apply a Pythagorean theorem, right? So it's going to be 3 squared. I don't know what this leg is. I'll just call it a. So we're going to square that, and then the hypotenuse is 2x squared. So 3 squared is 9 plus a squared. And then 2x squared is 4x squared. And then solve for a. So I'm going to subtract 9 from both sides. And then solve for a. So I'm going to take the square root of both sides. So a is square root of 4x squared minus 9. Okay, so now we can figure out our final answer. Our final answer will be negative 1 over 18 times sin theta. So what is our sin theta? Because we have our missing leg. So sin is, what is sin? It's opposite over hypotenuse. So here's theta. The opposite side, which we said was square root of 4x squared minus 9. So yeah, the opposite side is square root of 4x squared minus 9 over the hypotenuse, which is 2x. So it's a little bit confusing because we're going to get a complex fraction. So it's going to be 18 times sin theta, which is this whole thing. Okay. So we have to simplify this. So right, so we have a complex fraction. Our I'm going to multiply this entire thing by 2x, right? So on the top, negative 1 times 2x is negative 2x. And then on the bottom, when I multiply this by 2x, the 2x cancels, so you're just left with 18 square root of 4x squared minus 9 plus c. And then you can simplify the negative 2 and the 18, which can be, this will be reduced by 9. So my final answer is negative x 9 square root of 4x squared minus 9 plus c. Okay, and that's your final answer. Okay, yeah, that was a lot. So go ahead and copy and absorb. So that's a lot of work for one problem. Okay, I will end here. Thank you. Bye.